So this is our webinar today. We're going to be doing some setup of performance monitoring with our guest from Tonal. Max, we'll have everyone introduce themselves in a sec, but I just wanted to say Max, I think, has been an attendee at different workshops we've had in the past, and now we have him presenting. So if you are out there, you love Sentry, or you want to learn more about Sentry, come be a panelist someday too. We'd love to have you. Cool. So like I said, we're going to start out with quick introductions from everyone on the call. And then we're going to go right into looking at Max's from Tonal's actual Sentry config. And we're going to dive into his code a little bit too. So we will start with actually looking at his real data in Sentry and helping him understand where to start looking and what different stuff means. And then we're going to dive into his code base, or he has a tiny bit of performance stuff set up, but we're going to help him configure his performance setup to be more effective. And then I'll talk a little bit about what else Sentry can do, and then we'll open up the floor for Q&A. Great. Okay, let's do introductions. I can go first. I am Shanna, rhymes with banana. I use she, her pronouns. I am a developer advocate at Sentry. I am mostly being MC today, keeping the floor open to my awesome other guests. Lazar, why don't you go next?
Yeah, hi everyone. My name is Lazar Nikolov. I come from North Macedonia, also a developer advocate at Sentry, and I'm glad to be here. Thank you.
Awesome.
Hey everyone, I'm Adam, one of the senior engineering managers here at Sentry. I manage the performance team. I also manage our Toronto office, so I'm based out of Toronto, Ontario.
Perfect. Max, you wanna wrap up our intros?
Sure. Hey everyone, I'm Max from Tonal. I've been at Tonal building our mobile app since 2018. We built our mobile app in Flutter. It ships to both iOS and Android. And it's just been a blast working at Tonal these last 4 years, building this app and the company. And I'm super honored to be here today to share our insights and to learn a little bit with all you.
Amazing. That's great. I'm going to stop sharing my screen. It's really great that we have some from Tonal. I don't personally own a Tonal, but I've known about Tonals for a long time, and I think they're super cool. When I was in an apartment, I was very, very excited about the idea of potentially owning a Tonal. I do just own like a full squat rack gym situation in the garage now, but if I didn't have a massive garage, it'd be a great option. I'm curious, as we're getting started, Max, feel free to why don't you talk a little bit about where you're at right now with Sentry at Tonal, and kind of what motivated you to start looking into performance. And I'm also curious for people here joining, does anyone own a Tonal? I'm going to start a little poll. I'm curious if anyone here does. Okay, poll started. Awesome. Yeah, Max, feel free to take it away.
Yeah. I'm just trying to answer this poll. Oh, hosts and panelists can't vote. There we go. That explains it. I don't count anyway. Yeah, let me talk a little bit about Sentry here at Tonal. So we've been using Sentry for a while now, 3+ years at least. And we primarily use it for error monitoring because we want to make sure that we have a totally crash-free, bug-free experience for our users, and Sentry makes sure that that's the case. And so we're really keeping a close eye on Sentry while all the time, especially during our QA periods where we are really checking to make sure that we're not shipping anything bad to our users, because updating a mobile app on the fly is not really possible. So if we ship a bug, then that's out there now. So Sentry really helps us keep a close eye on the errors that are happening in the app, the crashes that are happening, to make sure that we can fix them before they go to our users. And it's been super effective for that purpose. But we thought, Sentry now supports performance monitoring as well. And I took a quick look at the docs, and we had to add one line of code to enable the performance monitoring. So I thought, why not? Let's do it. Let's see what it can give us. And next thing we knew, we shipped the update and we started getting tons of transactions into our performance dashboard on Sentry. And that's where we're at today, mostly, is that we kind of just set it up. We just set up the sampling and enabled it, and now there's data in our dashboard, and we're not quite sure what to do with it yet, and that's why we're here.
Awesome. Thanks, Max. Yeah, we have a couple different people here who can help you with different aspects of getting started. Adam, I think, is going to be the first person chatting with you. Let me get him like spotlighted for everyone so we can see both of y'all's beautiful faces. Wonderful. Awesome. Okay, great. I think the first thing we were going to do is just have you two go ahead and look at Tonal's Sentry setup.
Yeah, let's do it. I'll share my screen right now. All right. How's it looking? You see my dashboard?
Yeah, it looks
Perfect.
good to me.
Yeah, so this is
Great,
kind of
yeah.
Max is the homepage of performance, as you mentioned. It's kind of a dashboard. It gets you started in trying to highlight the things that are most important for you. So since you're using Flutter, we kind of default to that mobile tab. You can see along the top. You've got like all transactions, web vitals, front end, back end, and mobile. You can switch between all of them for mobile. All transactions in mobile tab would be the most important. If you ever kind of instrument your back end, then you would probably go to the back end as well. The general concept of this dashboard is really how do we highlight the things that are most important for you? So along the top, you see like transactions per minute, cold startup time, warm startup time, most frozen frames, most slow frames. You can also, in those like the ellipses, you can change that if you want. So you can actually change it to a different view. We can show errors or trends, but this is the default. So yeah, it's interesting. Like just looking in, nothing really stands out right away. Like you've got a couple of transactions that really highlight the slow and frozen frames. So if you wanted, we could kind of jump in and start looking there, or we can go to a specific transaction and really start diving into that. Yeah.
Sure.
Just looking through it.
Yeah.
Yeah, why don't we go to so normally from here I would start looking at kind of the different areas of my application. So I would go down to that transaction table at the bottom, and I personally would probably click through to one of those transactions, whichever one is most interesting to you. You know your app the best.
Yeah. Let's try the Explore tab.
Cool. So this is the transaction summary page. We're now kind of one level deeper where we're starting to like look into various parts of our application, and there's a bunch of different ways that we do that here. You can see kind of the first main thing that you would see is probably that duration breakdown. We take all of the transactions, and you can see that there's some interesting data here, a lot where you have like some 5 minute, some 1 minute transactions. To kind of get a better understanding, you may want to kind of toggle off those P90 views, which you can kind of do. Or we can start looking at, you can like drag and drop to really narrow in on a region. If there's a specific region that's interesting. As you go through this, it kind of narrows it in. You can start looking at that transaction table and start looking at the different sets of events. We've also, along the right-hand side, there's just more information that you can start diagnosing. So we have like user misery, which looks at how long transactions take for certain users. Yeah, we love miserable users here, and it's a way of seeing like basically impact of performance and how bad of a time users are having.
Cool. Great.
Okay, so we've also got like suspect spans. If you go a little further down, we're going to talk about that in a little bit, and suspect tags. Here we're really trying to focus in on like what are areas of your application or what are segments of your user groups that are having issues, and what may be the problem. So you can see like there's one specific app device that is 5,322% slower. My guess is that's one person that's having a hard time. And then suspect spans are really starting to look into that waterfall that we'll see soon of like where are you having problems in your application.
Cool. Very handy.
Okay, why don't we, so once I'm in this view, normally what I would do is go into an individual event, and basically what I'm trying to find is like, what does an individual event look like? Where are they having a problem? So why don't we click on one of those events? Cool. So here we get a little bit more information. So you can see like there's all of these tag details. So for this individual event, you can find out more about your user, the device that they're looking at. That breadcrumb section is kind of all of the things that they do throughout to get to this point. The one thing that I've noticed here is so for a lot of our SDKs, we have a lot of automatic instrumentation. Flutter is one of our newer SDKs, and we just don't have as much instrumented right now. So we're just seeing that one navigation span. So there's not a ton of information that we can glean from that yet. And one of the things that I would do if this was me at this point is kind of build out that waterfall. So add some of that custom instrumentation into my own application to really narrow down that performance and like understand all of the different aspects of it.
Awesome. Yeah, we'll do some of that, and we'll see what we can do.
Yeah, so why don't we do that now? I think Laser is going to come on and help you out with that.
Sure, great. Yeah, let's jump into that. So first, I just wanted to pull up the Sentry docs here, and yeah, because this is the documentation on automatic instrumentation for Flutter. And so in particular, I think we're interested in the HTTP client library instrumentation because we're looking at these API transactions, and some of them are quite slow, like this one. We don't understand why yet. So we want to add some more detail. And it's really cool because it looks like Sentry makes that easy for us to do. And I noticed that there's more information here on the performance monitoring for HTTP requests. And if we just take a quick look at this code sample, I think what it's talking about is starting a transaction and then making the API call and then closing the transaction. But I think what we want to do is make a transaction that includes multiple spans to talk about or to show the various stages of work happening on the client side for these requests. I think it'd be super helpful if one of you could help explain to us what is a Sentry transaction and what is a Sentry span before we move forward.
Yeah, I can help walk through that. So a Sentry transaction is like a concrete piece of work in a user journey. So think of it in this case as like the user hits your mobile application, that starts a transaction. And then until they do something else or until there's a timeout, it would capture all of the events that happen in that. And all of the events that happen in that are spans. So an example of a transaction would be like they hit your app or the Explore view in your application. And then maybe that Explore view does a bunch of HTTP calls to fetch data. It may do a bunch of, it may render a bunch of components. Those would all be spans within that view. And with distributed tracing, you can have your front end all the way to your back end. So you may see a span in your front end that's like an HTTP, like an API request to your back end. That is both a span and a transaction. So from a data model perspective, they're almost the same thing. It's really just how it's viewed. And if you've set up your front end and back end, you can actually go from that span in your mobile application and link it directly to your back end application. And then you may get more details there.
Amazing. That's super helpful.
Yeah, thanks for that explanation, Adam. Yeah, I'd love to I think we're ready to move on and get to the code, but I just wanted to say we've got some great questions already, so I thought I'd throw them out there. I know it's not specifically Q&A time, but just as we go. So first, one person asked, they were confused about their own setup. They're asked, like, what if the only area that's populated in my Sentry performance tab is the most related issues chart. And so they actually figured this out, but I wanted to mention it in case other people are running into a similar issue. So the problem that they had was actually that they had an environment filter on that was causing it to like filter down, which I think it was an easy mistake for them to fix, but probably also a very easy mistake for folks to make. So do be careful. Like if you're not seeing data show up and you're pretty sure it should be, make sure all your filters are set appropriately. Another question that we have so far is there a way we can monitor external APIs? They're looking about GraphQL APIs that are developed by a third-party library. I wonder if, Adam, you could jump in.
Yeah, absolutely. So the answer is kind of it depends. If you are hosting your own, if you're hosting kind of that yourself, we do have kind of an API that works into it, or an SDK that works into it. If it is like a totally self-hosted, or if it's its own thing hosted on its own service, what you could do is kind of wrap the start of it and the end of it as a transaction and just name it like GraphQL, and you can't see why it is slow, but you could see that it is slow or hopefully fast. So it kind of depends on how you're doing it.
Yeah, awesome. Thanks, Adam. Yeah, and if question askers, if the answers we're giving haven't answered your question fully, feel free to pop back in the chat. Or I think once we do a Q&A portion at the end, we'll raise your hand and we can unmute you too and let you chat if you want to have a live conversation with folks on the call. Cool. Another really interesting question that I definitely don't know the answer to is, what performance footprint does Sentry itself add to performance monitoring?
Yeah, that's a great question, and one I was trying to answer in chat, but Zoom apparently doesn't shift enter. It depends on the SDK. And it really depends on the language and the framework. For some, it's as low as kind of like 1 to 2% like total duration, and some it's a little bit more, but overall it's not that significant. We do have, I'll try to find the repo. There is some data that we've pulled, and we do run tests on the performance of the SDK. So it's somewhere, and I will link it in chat. I just don't have it off the top of my head.
Awesome. Okay. There's a question in Q&A that someone actually wants us to explain again in detail the information we can get from the suspect tag section. Do you want to just pull that back up and have Adam walk through that a little bit more slowly before we move on?
So if you go, go into an individual transaction. Yeah, so suspect tags and suspect spans are very similar, where spans looks at individual spans on a transaction. And as we saw, there's only one on these transactions, and tags look at kind of all of the tags associated with a transaction. There's a few different pieces of information, but what we're trying to do here is really highlight. For spans, we're trying to highlight, hey, this span may be a problem. Like, you should look at this and investigate to see if this is actually affecting your performance. And for tags, we're trying to narrow down the population of your users to really be like, oh, in this case, we think that app device is causing this slowdown. Now, in this specific example, the data looks a little interesting, and Max, we probably don't have time here, but eventually we can kind of dive into that and see why. But what we're showing is like, for a given tag, so in this case, let's use the top one, it's app device. For that tag value, that's the duration or the average duration of that set of users that have that tag. You can see the frequency, in this case, it's 1%, which really makes me think that it's probably a single device in this case. And then you're looking at like compared to average and total time loss. And what that is showing is like, this is the amount of time that is taking, like the total amount of time if you add up all of the durations of those transactions that have that tag value. And then you're just comparing it against the average for the entire set, regardless of tag value. So you're really trying to narrow down, like, if for a web app, if my user is on Chrome, they are by far slower than everyone else. And maybe you're using something specific to Chrome that slows things down.
Awesome. Yeah, that's very helpful. Thank you, Adam. Great. The last question we had was, do you have any, or for now at least, do you have any setup examples for Roku clients? I'm not sure I can think of any. I can do some searching while the rest of the workshop continues and see if I can find anything for you, Michael. Cool. Okay. I am seeing a couple more questions come in, but why don't we oh, okay. No, we'll answer this one. David says, if you're working on a single page web app, and when we go to the performance tab, we're seeing paths under the transactions table. Is there a way we can give custom transaction names if you're using automatic instrumentation?
Yes, you can. If you instrument it yourself, it will kind of take over. So why don't we move on to the next part where Max and why don't we do that, and then we'll see how you do it.
Yeah, this is a perfect question to lead us into the next section. Awesome.
Great, an awesome segue. All right, so what we're gonna do again is we're gonna do this. We're going to see if we can implement basically what the docs are suggesting here. And I'm gonna unshare this, and then I'm gonna share my code. So I'm dropping the link to these docs in the chat if anyone wants to reference it while we are doing code. Okay, here we go. Share screen, VS Code. All right, welcome to the Tonal mobile app code base. What we're looking at right now is what we call the Tonal HTTP client, which is simply wrapping the Sentry HTTP client, which itself is wrapping the official HTTP client. So, you know, some classic hierarchical, what's it called? You know the word. Anyway, moving on. This file is
I call it shims on shims, Max. That's what I call it.
Shims on shims. Inheritance.
Yeah,
That's the word I'm looking for.
That's a more correct term.
Slow brain today. That's okay. Anyway, the HTTP client. This thing we already have. It's already wrapping the Sentry HTTP client. And this file, it's super boring, but this is what real code in the real world looks like. It's little wrappers around basically all the HTTP commands that we want to make. And, you know, we're formatting the headers, taking JSON, converting it to strings, that sort of boring stuff. But today what we want to do is we want to instrument this a little bit better. So firstly, the docs recommended that we add network tracing true right here. So I'm just going to go ahead and do that. Adam or Lazar, do you want to explain what this is doing?
Sure. Sorry. So I'm not a Flutter expert. So on this one, it looks like it's capturing all of like the network calls as spans. That would be off the top of my head.
I think that's right. So it's really easy to do that. We just add that there, and that's done. This is a shippable change. I think that we'll get a win out of this just alone. But the docs also suggest that we want to maybe collect some more information manually about these HTTP calls that we're making, and then the data munging that we're doing afterwards. So a little bit of background on the Tonal mobile app is this app is built with Redux. And so the API calls that happen in the mobile app go through a life cycle where first the API call is made, the response comes back, and basically in the form of a Redux action that gets taken in by Redux, which then converts the response that it gets, which is a string, into a deserialized Dart value, which it then stores into Redux, which then gets persisted to disk. And so there's a whole bunch of stages that happen here. It's the API call, then it's the data transformation, deserialization, and then ultimately storing to local storage. And so it'd be interesting to start a transaction to wrap that kind of whole process, right? So maybe let's just go ahead and do that. We need to go to the API.dart file. So this is another really boring but very important file in the mobile code base, and it's our API class. This is the class that we use to make every API call in the mobile app. And this is the only thing that's calling the Tonal HTTP client directly. So this itself is a wrapper around Tonal HTTP client, which is a wrapper around Sentry HTTP clients. And you can see again that we are basically wrapping get, post, patch, delete the HTTP methods. And ultimately, there is a function down here called make API call, very clever name. But basically what this function is doing is this is the thing that's actually invoked when you actually make an HTTP call from within the mobile app. It's handling the nasty stuff like you setting up file names for JPEG posts and wrapping the headers appropriately. So this isn't the best spot to start the transaction because ideally we would start the transaction somewhere a little bit higher up, but for the sake of this webinar, let's do it right here maybe. Looking at the docs that I linked in the chat, we'll just go ahead and start a transaction. Final transaction, Sentry.start. It already is complaining because we don't have Sentry imported. We'll go ahead and do that. Sentry start transaction. Okay, and so the name of the transaction can be anything. It can be anything that we want it to be, but we want this transaction to be named something specific about this particular event, which maybe we can just use the name of the endpoint. Does that make sense?
Yeah, totally.
Great. Let's do that. To string. Okay, the next argument is the operation. Should this be the like the method, or should it be a static string? The docs weren't super clear. What do you all think we should do with the operation?
Maybe we can even merge them. For example, we could use the method that comes from the API request and then pass on the endpoints. It's like a get /user/ something, or like get /explorer, etc. So we could, yeah, we could do a concatenation of these two as the description.
Something like, oh, for the description. Okay, 1 second here. Let me put this back. So we'll say, okay, so we'll say this. What's it complaining about? Oh, it's just we don't have the other argument yet. Okay, so maybe the first argument, which will be the again, the name of the transaction, followed by the operation.
Yeah.
Is this what you were suggesting?
For the operation, it's often best to, like, we do use the operation in different areas, so it's best to kind of standardize it. In this case, it could be like, this is an API call, so you could do like API, or something kind of straightforward. Yeah, you could do HTTP. That's perfect.
Great, awesome. And then
there's a breakdown on the performance page where you can actually look for all of your transactions and spans that have HTTP operations.
Cool. Okay, great. So it sounds like we should probably just leave that static, but I kind of like the idea of having this be the name and then this be the operation, if that sounds good to you all. Sweet. Okay, and then the last thing was just bind to scope true that we want to include there. Great. Okay, and then before we forget, let's make sure to finalize this transaction. At some point, again, we probably want to move this up to a higher level since we are going to be trying to do multiple things, but for the sake of this, let's just make sure that we do finalize it. So we'll do await transaction.finish. When you finish a transaction, you have to provide a status. So we'll just do okay. All right, how does that look for the transaction? This is just the setup part.
Yeah, totally. And for example, we can even try to finish the transaction within the catch and just pass on a different status, right? For example, in here, we're passing the status okay. If you wanted to, yeah, something like that with a different status. Now it all depends on the it depends on the exception that would happen, right?
Yeah. So ideally, I guess what we would do is we would actually do like, if the HTTP status is a 400, we probably want to do a forbidden of some kind.
There, sorry, there is a, yeah, there we go. If you've noticed that from HTTP status code, we can actually parse the HTTP status code.
Oh,
into
that's even
status.
better. Let's see here. Okay, so this just needs the HTTP status code. Well, guess what? I think we should have that handy because it should be, let me see. Well, it may not be super easy to get it. Oh no, it should be. It's in the response. Response dot status code. Look at that. So easy.
Yep.
This is not a constant anymore. Formats. Great. Okay, that's even better. So this should not be a finally. This should be a actually, I don't know. I don't know what this should be. Anyway, we'll deal with this later. but you all get the idea here. That is very cool. I did not know about the from HTTP status code feature. That rocks. All right. So the next thing we want to do is create a span. And we're going to do something a little bit silly, which is basically just wrap this whole thing also in a span. Although in the real world, we're gonna move this somewhere else higher up in the app. So just imagine it's somewhere higher up for now. We're also going to start a span, right? So final span equals, and we can just piggyback the transaction directly, do start child. And so the operation here, should we do a static name for the span? And then maybe like it also takes a description. So we can also pass the description here. Maybe the description is just this thing again.
Yeah, as you notice, there is no name because every child span is hooked to a certain transaction, and the child kind of inherits the name from the transaction itself, right? For the operation, I don't know. For example, right now it's pretty vague because we have both of these things into one. But for example, if we were to measure the whole, data fetching and data parsing and rendering, etc., the operation would be something more precise, or like something more concrete for the actual purpose that we're using this child span, right? If it was like rendering, it would be rendering the results or etc. But for now, I don't know, we could probably leave it like HTTP because it's true, right? This whole child span actually measures the HTTP. But yeah, in a different scenario, we would be more precise, for example, with the operation as to what that actual child span is measuring.
Cool. That makes sense to me. So maybe just a small change here is to say like the transaction is wrapping the entire API call, which includes the HTTP request as well as the data transformations or whatever. So maybe we just want to call this API, and then the span is the HTTP request, like the granular, like just the request.
For example, for the transaction, we could say that the transaction is populate explore screen, right? And the child span could the operation could be either HTTP or data fetching, as you wish. Yeah, you could, or you can like leave it as HTTP, right? So for example, the overall populating the explore screen involves a few more steps than just data fetching. When we actually set up that structure and start looking at the data that we get in Sentry, we'll see, okay, the data fetching took that much time, the parsing took that much time, the rendering took that much time, and then using these child spans, we can zero in on exactly which part is taking the longest and where can we do some optimizations. But yeah, in this case, it's pretty okay to leave it like this.
Cool. Yeah, that makes a lot of sense. Ultimately, we definitely want to move the start transaction so that we can get a bigger picture of whatever it is that we're trying to capture, but definitely a bigger picture than what we have right here. So I've created this span. Do I need to finalize this span?
Totally. Yeah. And that needs to be finalized before the transaction is finalized. Yeah. So when we
great. So we'll just go down here then.
Yeah. Await child span, or like child. I'm not sure how you named it.
What did I call it? Span?
Yeah. Not finish. Exactly. It's going to take all the measurement data with it, and it's going to append it to the main transaction, right? So if we don't finish it, the main transaction will be sent out without that child's data.
Great. That makes sense. So let's just wrap it up. All right. So of course, in the real world, we're going to have the transaction.finished somewhere else. But the point is that it's finished so that it does work. We can refactor it later. Okay, cool. So it looks like we have an actual span around this. I think it would be cool to add one more span, which is around our data transformations. So I mentioned that we're using Redux. And basically, so every API call is dispatched and comes back and gets converted to a Redux action. So it dispatches this like API success action. And that API success action contains all the details about the request as well as the response from the API. And the job of this monster function is to take that API success action and to convert the response into some serialized Dart data that can be inserted into our Redux state object. And so we have basically an enormous switch statement here for every type of API call that we have in the mobile app. And we've written a little reducer. The reducers are pretty unexciting. They are deserializing data and inserting it into Redux we're using built value, which we love and also hate, but mostly love, but also hate. And so it's pretty cool, somewhat. Take a look at it or don't. And we're using built value. So the deserialization code is mostly about that. Anyway, so I think what we can do is we can wrap this entire reducer with a span, just to say, like, you know, this is where the data transformation happens. If there's going to be slow data transformations, it's going to be inside this function. So I propose that we just like kind of wrap this whole function. Here's what I think we should do. Make this one private and then make a whole new one that just returns this thing with the parameters. So now we have a clean slate to wrap. Okay, cool.
That's a good idea.
Thanks. Yeah, it'll keep things simple. We don't have to scroll up and down. Also, you notice that all the switch statements return directly, so it's kind of difficult to do it otherwise. Anyway, so yeah, let's just create another span here. We're gonna go ahead and do span Sentry. Okay, so this time we don't have the transaction handy.
Exactly.
So firstly, I'm going to import Sentry so that we have it. But yeah, we don't have the transaction. I don't think we want to put it in a global file or anything. So what can we do to get the transaction?
Well, if it was really simple, right? The one way and like maybe the laziest way that we could think of is just pass it in the arguments, so we can reuse it. But not in this case because we have a reducer, right? We can use the getSpan method from Sentry directly. There we go. And if we are within the scope of a certain transaction, the getSpan is going to return that transaction. That would be the main transaction, right? If there is no,
awesome.
then the span will be null. Yeah.
Cool. Well, that's super helpful. So we can just call getSpan here. It won't actually be the transaction that we just set up because we didn't put it in the right spots. But you can imagine that we did, and it's getting the transaction that we just set up. Okay. So what we want to do is actually start a new span here, right? So we'll do start child. And the operation here, we'll call this reducer, maybe. And then, yeah, just the description. I feel like this is a little bit redundant perhaps, but maybe we can add this as our description. Yeah, let me just format this. Okay, we got some red lines here. That's because request is not defined, but good news. We do have access to the request. It's very easy. It's under the payload of the action. So now it exists.
Yeah, we can also loop in the I don't know, some other stuff from the action, maybe like the name, etc. Right? Oh, we're handling the endpoints, which is pretty much the same. Yeah, exactly. So I think we can always add more info, but I think that should be good for now. And then we need to finish it, right? Okay. Yeah. So actually, we don't actually need to return anything from this function. It's void. So we can move on and just do span, and we'll say we'll finish this span off. It's really not possible for this to do anything except for be okay. So we'll just say that. Awesome. So this should now trace the performance of all the reducers. Not very much code to do that. That's pretty cool. So I think that pretty much wraps up what we can do with HTTP instrumentation without going into too much more detail. Yeah. What do you all think? Do you have more ideas?
This looked
I think this
awesome.
is. Yeah, sorry, go, Shanna.
Oh, let's see. Okay, my video's back. Okay, great. Yeah, this looked awesome. It's really, really cool to see you actually changing this stuff live in Tonal's Flutter app. It's really exciting. I know maybe Lazar, you can talk a little bit about, I know we can't do anything where we set up traces between the front end and back end today, just because we're only dealing with your Flutter apps code, but maybe you could talk a little bit about like what that would look like in theory.
Yeah,
Oh,
totally.
yes, that's a great idea.
Yeah, there is a way to link or like to reuse a single transaction between the backend and in the front end or the mobile app, even though we're not talking about the same technology and programming languages, etc. We could be using the Sentry trace HTTP header when we're doing that, right? So for example, we could be opening up a transaction on the client side, whether that's a front end in React or if it's a Flutter app, regardless, we can open that transaction, and there is this Sentry trace method that returns a lot of info like the trace ID, the span ID, etc. We can use the trace ID and set the header of our request to that trace ID as the Sentry trace header. Then we can obtain the trace ID from the headers on the backend, right? So we are making the API call from our client to our backend. We can obtain the trace ID and basically create a transaction from that trace ID, right? So we're basically recreating the same transaction we created on even on a different hardware, right? Because it's a phone and there's a server, and then we can move a lot of the data, for example, that we can monitor on the backend alongside within that same transaction. And then we can pass it down, even pass it down further to monitor and to actually, to measure the performance of obtaining the data and parsing the data and the rendering the data on the screen. So basically the whole life cycle, or like the very beginning of the beginning and the end of the whole operation, including the backend, can be put into a single transaction using that Sentry-trace HTTP header. So that's pretty cool.
Awesome. Yeah, I think we got a question about this, which I didn't even see when I asked you to talk about it. So I'm like reading people's minds. Yeah, the question was from someone anonymous. We currently only monitor our Angular front end. Can you show what we have to add, configure, set up, etc., to integrate our .NET API backend into the existing project? So we can't specifically show it today. Apologies, but yeah, hopefully Lazar's little talk through was helpful. Yeah, and let us know if there's other info that we can help you with. We did get one other question that I was going to mention right now. How does Sentry understand that the transaction.finish is for X transaction and not Y transaction? Because it's not really inside a scope of code. I don't know. Maybe Adam knows the answer to that one. No, we don't all know all of the magic of how Sentry works, unfortunately.
Yeah, well, when we're creating a transaction, it has its own unique ID, right? So when we are finishing that transaction, I believe using the reference of the actual variable, that's how we can, that's how, for example, when we're finishing a transaction, we know which one we're finishing, because even though every transaction has its own unique ID, right? And based on the reference of the variable, when we finish that one will be finished, I believe.
Got it.
And you,
okay, yeah.
if you're finishing it down lower, you'd have to like pass it through.
Yeah.
But yeah.
Yeah, that makes sense. Okay, awesome. Great.
Cool. Do we want to go back one sec? I think that we could probably add the Sentry trace header to the mobile app right now if we have time.
Sure. Yeah, we have about 13 minutes left before we got to wrap this up. But I think that's plenty of time to do that, and then leave some time for Q&A as well.
I think it's just going to be 2 lines. So let's see, because I think this is going to be like, obviously we can't do the whole end to end, but we can start it on the mobile side so that the back end can pick it up when they have an opportunity. So yeah, let's go back here. We're familiar with this, this make API call function. Well, it uses another function called get headers, which basically is wrapping our request and adding some headers, authorization headers, app version, device ID, time zone, that sort of stuff that we want in all the headers. We want to add another header to basically every request now, the Sentry trace. So what we need to is a good place. So let's go ahead and make a Sentry trace object. We'll do Sentry.getSpan, which we're familiar with now. And now there should be some sort of trace function in here to Sentry
to
trace,
Sentry
right?
trace.
Great. Now that is not a string. That is a Sentry trace header object. So we want to get the ID out of it. The trace
Yes,
ID.
is trace ID, yeah.
Trace ID. Okay. And then we can convert that to string. And we'll just, we'll just pass it to the header if it's not null. If it's null, then we're not going to do it. And you said that the header is Sentry dash trace.
Dash trace, yeah.
Brilliant. Exactly. All right. So just like this, we're passing a Sentry trace ID to our backend, which can then use it immediately to start setting up more spans on the backend. That's very cool.
Yeah, very cool. Next time we gotta get a backend dev on next time from get both going.
We'll do our best. Yeah, it'll be really fun. Have a little Dart Go dual demo.
Ooh, I love it. I love it. That's super exciting. Okay, great. I think we want to get to a section where we just let Q&A happen pretty soon. I was going to talk through just a couple things that Sentry also has that we couldn't really show today during the demo because of some tech limitations. It's newer stuff from us. The first thing is our profiling feature. So if people aren't really familiar, profiling is basically like deeper insight into why slow performance is happening. And it actually calls, or it captures every function call that's happening in a given operation. This we just released, and it's only in beta right now for iOS and Android, not Flutter. So why we couldn't really talk about it today with the Tonal project. But if you yourself have an iOS or Android project, please check it out and give us feedback. It's also going to be coming out to our support for Python, Node.js, and Rust. I believe Rust, yep, are coming out soon too. So if you use any of those, be on the lookout. Another cool thing we've launched, thanks for sharing that link, Sasha, perfect. Another thing we've launched recently are performance issues, which performance issues are really cool. It's basically Sentry, if you have performance instrumented in your project, Sentry can automatically detect certain kind of things you haven't maybe done properly or ideally in your code that could be causing a performance issue. Right now, we currently just detect N+1 issues in Django. So this is super beta, but I could say we have already detected an N+1 issue on the official Django project's website and helped them fix it. So we're doing something right. N+1, in every backend. Thank you. Sorry, it was just Django for a sec, I think, but now we have it for a lot more stuff. So PHP and Ruby and Node, maybe more stuff too. Awesome. Great. Okay, I think we want to turn it over and just do some Q&A if any folks have more questions. We actually even have some other folks from Tonal who are on the call. So if you have questions about Tonal in general or Sentry in general or anything you saw, feel free to drop it in the chat or in the Q&A function. And if you would like, we are more than happy to let you come off mute or even say hi, show your face if you would like that. So go for it, friends. I can start off with a question. I know you mentioned your backend is in Go. I've been wanting to learn Go. So I'm just curious, why did you guys choose Go for your backend? Maybe you don't have the answer to that, Max. I apologize.
It's a good question. I'm not a Go engineer, and I haven't really written much on the back end. I can speak a little bit to the history though. What we like about Go is a few things. Number one, it's a statically typed modern programming language, and which meets the criteria across our stack, where we use Kotlin to build our Android app. We use Dart on the mobile app, and we use Go on the back end. These are static, modern, typed languages. And so we love that about Go. The other thing that's really awesome about Go, it's super easy to deploy because what you're doing is you're taking all your Go code, you're compiling it to a single binary, and you're just shipping the binary to production. In contrast, a Node.js API requires you to, take all of your code, then download all the Node modules, and then bundle this enormous package of tons of files and ship that to all of your servers. And that's a much more intensive task. They can get really tricky, actually. So Go is super easy to deploy, another reason we love it. So, and the other thing about Go, it also has a very limited syntax. So it's relatively easy to learn and people can pick it up pretty quickly. So yeah, for all those reasons, Go has been an awesome language for our API.
Love it. That's awesome. Yeah, that aligns with everything I know about Go myself. As we do have a couple of questions coming in, but I wanted to launch another poll to ask questions of the attendees. I'm curious, this is kind of a little bit of a different format than we've done. We usually don't have so much live coding happening during our workshops, but we hope it was helpful. So I just launched a little poll for y'all to ask you if this was helpful. Did this help you get insight into how to set up your own performance configuration for your project? I know it was Flutter and probably not everyone's using Flutter, but hopefully I think the concepts were going to be the same. And I think your code, I thought your code is very understandable as someone who has no mobile dev experience. So awesome. Cool. One question for us, how do you manage the HTTP logging when using Lambda functions? This needs to be tied to a service does this need to be tied to a service like API Gateway? I'm not sure.
Off the top of my head, no, but it's been a long time since I've used Lambda. We do have an SDK specifically for it to track, and it does do a decent amount of automated instrumentation. So hopefully out of the box, you can get some value, and then you can, similar to what Max did, you can wrap certain things yourself. But specifically, if it needs to be tied to a gateway, I'm not sure.
Yeah. I'm going to find the link to the Lambda SDK to share. Okay. Okay. Check any other questions. It doesn't have to be necessarily specific to what you saw today, but any other cues for Tonal folks at Sentry? Ivan says, maybe not related to perf or monitoring, but does Sentry have a centralized approach to hide or mask user PI data?
Yeah, so there's a lot of things that we do automatically. We look at specifically around tags, we look at the name of it, and if it falls under if it's called password, we mask it out. If it's called key, or there's a lot of things that we do automatically. And then in the settings, you can add your own for PII and making sure that it doesn't hit our servers. So there's a lot of controls around it. We obviously take this stuff very seriously.
Yeah, awesome. Oh, this wasn't a question, I think. Oh, Jill just says, understanding the span transaction relationships and instrumenting the code was super helpful. Thank you. Yes, I agree. Awesome. Glad to hear it. Cool. Okay, I'll give a few more minutes or, a little bit more for questions, but otherwise we can wrap it up. Yeah, I appreciate all of you, and especially Max, thank you so much for being willing to come on and show your actual data in Sentry and show the actual code. It was really great to see. I think for me, it felt super helpful, and I'm sure it was helpful for folks on the call, getting just the experience and talking through how to get some of this stuff done. Cool. Oh yeah, Sasha.
Thank you for inviting me.
Oh, Pooja says, this was super helpful since we do use Flutter in our code base. That's awesome. That's awesome. Super. Okay. Yeah. Sasha is from Sentry. She's from our team. And she asked all of y'all if there's anything else you'd like to learn in the next session. Please let us know. If you have thoughts after you hang up here, what's the best way to contact us? You can reach out on Twitter. That would be great. Yeah. Add us on Twitter and let us know what you want to see on the next workshop that we do. Let me drop our Twitter in the chat. This is us. Twitter.com/get Sentry. We also have a Discord. Let me see if I can pull that up and drop that in the chat as well. Let's see. Discord. Oh, I'm going to end the poll. Thank you for everyone who responded to the poll as well. Appreciate it. Glad to see that this was helpful for and or people want more for almost all the responses. Okay. Oh, still getting some questions in the chat. Maybe Lazar, do you mind reading those out while I grab the Sentry Discord link?
Okay.
I just posted it.
Oh, perfect. Thank you, Adam. So on top of things. Awesome. Okay. Great. Ooh, my. Oh, so many great questions here at the end. Okay. Well, we probably won't have time. I'm going to copy all these questions. And you know what I'm going to do? I'm going to see if we can get them answered, and I'll drop answers to them in our Discord. How does that sound to everyone? So if you asked a question right here at the end, thank you. And we'll see what we can, you'll see your answer on Discord. Cool. Okay. Thank you so much for joining. All the Tonal people, really appreciate it. And also Sentry folks as well, and attendees. It was awesome to have you. Thank you for the great questions. Yeah, and have a wonderful November 1st, Day of the Dead. Okay. Bye, everyone.
Take care.
Thanks, everyone.
Bye.